Hello students, I welcome you all to my channel Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve these two problems which are related to this diagram. So it's from friction chapter, right? So the first problem says that the pipe of weight W is to be pulled up the inclined plane at slope alpha using force P. If P acts at an angle phi, show that for slipping P equals to this, where theta is the angle of static friction. And in the second problem, it is said that determine the angle phi at which the applied force P should act on the pipe so that the magnitude of P is small a is possible for pulling the pipe up the incline. What is the corresponding value of P? The pipe waves W and the slope angle is alpha. Express the answer in terms of the angle of kinetic friction. Theta equals to tan inverse mu k, and here theta equals to tan inverse mu s. Now this is the free body diagram of that pipe, and it is subjected to some force P at an angle of phi, and the slope is making some angle alpha with the horizontal. So now the weight of the pipe is going to act vertically downward. Let's say somewhere here is the weight of the pipe which is going to act vertically downward. So this is represented by W, and let me draw a line perpendicular to the inclined surface. So this line is perpendicular to the inclined surface. Let me move it a bit. Let's see. So now if I draw the normal force on the pipe, so the normal force on the pipe is going to act in this normal direction to the incline, right? So this is that normal force. And if this force P is trying to pull this pipe up the incline, so the friction force will resist its motion in the opposite direction. So we will have the friction force in the opposite direction. So let me show that friction force. So this is that friction force. This is the friction force. And this is, let's say, represented by small f. And here we are given that theta is equal to tan inverse mu s. So what is theta? Theta is basically the angle between the normal and the resultant of this f and n. So if we add up both of these, if I add up both of these, so the resultant will be acting like this. Let me represent it by some other color. Let's say this is the resultant. Let's say the resultant of this f, this small f, and this normal force is this. Let's say this is the resultant. So the angle between the resultant and the normal force is known as theta. This is that theta. So if I draw these three forces, this F, N, and their resultant, let me draw it here. This is force F. This is that normal force. And this is the resultant of these two. So this is that angle theta. Now we can draw that for small force F here as well. So we have this right angle triangle. And if I write tan theta, F divided by n, and as we know that f divided by n is mu s, right? So from this we can write that tan theta is equal to f divided by n is, from theory we know that this is equal to mu s. So from this we can say that theta is equal to tan inverse mu s, which is given in the statement that consider theta equals to tan inverse mu s. So wherever we have mu s, we can write it as tan theta. So we will have theta in our calculation, in the derivation of that force P which is required to avoid that slipping. So now let me remove this. This was the concept behind this angle theta. So, and let's say now as we can see that this W is acting in the vertical direction, which is, if I extend the line of action of this weight, so it is going to make 90 degree with the horizontal. And this normal force is this, this normal line, this particular line is perpendicular with the incline. So if the angle between this line and the horizontal line is alpha, then the angle between the weight and this line is also alpha. So let me write that this angle is also alpha. So now since this pipe is in equilibrium, so we need to apply the condition of equilibrium. So for that I have to resolve this force P. So this force P will have one component in this direction and it will have one component in this direction. So this one will be the cos component. This is P cos of phi, and we will have the sine component like this. This one will be P sine of phi, remember. And now if this angle is alpha, then we can resolve this weight into its components. So it will have two components. It will have one component which is going to act in this direction. This one will be the cos component. This one will be W cos of alpha. And we will have one another component of the weight which is going to act in this direction. So this green one is the sine component. And so while considering the equilibrium conditions, we are assuming that our x-axis is parallel to the inclined surface and the y-axis is perpendicular to the inclined surface. So now let me apply the summation of forces along y equals to 0. So the summation of forces along the y-axis, that is equal to 0. Since the pipe is in equilibrium, we are finding the force P to avoid slipping, right? It said that the pipe upward is to be pulled up the inclined plane of slope S if P acts at an angle this, where theta is the angle. So we have to find that P, so to avoid that slipping, right? So the summation of forces along y, so we have to add up all the forces or component along the y-axis. So first of all, we have this P sine of phi. This P sine of phi, this is acting in the positive y. This is our positive y direction. So our positive y is like this. So we will write P sine of phi. Then we have the weight component which is acting downward, that is in the negative direction, negative y direction. So we will write minus W cos of alpha. And similarly, we have this n. This n is acting in the positive y direction, so there is plus n. And this is equal to 0. Similarly, if we apply the summation of forces along x, the summation of forces along x, that must be equals to 0. So the summation of forces along the x-axis, this is equal to 0, and up the incline is considered as positive. So now we have this P cos of phi, it is acting in the positive x, so P cos of phi minus this weight component which is W minus W sine of alpha, and then we have this friction force. So this is acting in the downward direction, so this is minus F. This is equal to 0. And from this equation, we can write that F is equal to tan theta n. If we consider this, so F is equal to tan theta n. So this is F. So now we can replace this F by tan theta n, and this is equal to 0. So now from this first equation, we can write this n. So this n will be equal to W cos of phi minus P. This is W cos of alpha minus P sine of phi. And now if we substitute this n into this equation, so this will be P cos of phi minus W sine of alpha minus tan theta into n. So n is W cos of alpha minus P sine of phi. This is equal to 0. So now this will be P cos of phi minus W sine of alpha, and if I multiply this inside, so this will be W cos of alpha tan theta, and this will become minus into minus, so that will become plus P sine of phi tan theta. This is equal to 0. Now we will keep these terms having P on the left hand side and these terms on the right hand side. So this will be P cos of phi plus p sine of phi tan theta, and this is tan theta, and this will be equal to w sine of alpha plus w cos of alpha tan theta. And now if I replace this tan theta by sine theta divided by cos of theta, since tan theta is always equal to sine theta divided by cos of theta, so we can write this tan theta is sine of theta divided by cos of theta, and similarly here we have that tan theta, so this tan theta can be written as sine of theta divided by cos of theta. And now let me multiply both sides of the equation with cos of theta. So we will multiply both sides of equation with cos of theta, so we will cancel out this cos of theta. So if I multiply the left hand side with cos of theta, so we will have p cos of phi cos of theta plus p sine of phi, and with multiplying cos of theta with this term, cos of theta will cancel out, so we will be left with p sine of phi sine of theta. And from both of these terms we can take this p as common, so we can write this as like this, and this is equal to from and if I multiply cos of theta with this, so that will be w sine of phi cos of theta plus w cos of phi, and multiplying cos of theta with this term, cos of theta will cancel out, so we will be left with w cos of phi sine of theta. And similarly we can take this w common from both of these terms, so this will be like this. So now, as we know from trigonometry that cos of alpha plus beta, or instead of alpha plus beta we can write that let me write that this will be cos of phi minus theta, this will be equal to cos of phi cos of theta plus sine of phi sine of theta. This is from trigonometry, right? So as we can see that this is this term, so this means that we can reduce this to cos of phi minus theta. And similarly we know that sine of alpha plus theta, this will be equal to sine of alpha cos of theta plus cos of alpha sine of theta. So this means that this is equal to sine of alpha plus theta. So now we can write this whole equation is p cos of phi minus theta equals to w sine of alpha plus theta. So from this we can write that p equals to w sine of alpha plus theta divided by cos of phi minus theta. So now this is the solution for the first problem, since it is said that if p acts at an angle phi, show that. So we have shown that this is p is equal to w sine of alpha plus theta is equal divided by cos of phi minus theta. So we came to this conclusion, right? So we have proved this. So this is the solution of problem 8-9. Now in the next problem it is said that determine the angle phi at which the applied force P should act on the pipe so that the magnitude of P is as small as possible for pulling the pipe up the incline. What is the corresponding value of P? So now we have to find the phi value. We have to find the phi value for the second problem, and then according to that phi we have to find the P value for problem 8-10. So, and we have to find this phi for minimum P. So in order to have minimum P, we need to have the derivative of P with respect to phi equals to 0. So this condition applies for both maximum and minimum. So we will apply this, and then we will find out the condition for the minimum value of p. So now first of all we have to take the derivative of this p equation with respect to phi. So with respect to phi, this w and this sine of alpha plus theta, they are constant. Only this cos involves the angle phi. So for that, if I take the derivative, for taking the derivative, let me write p equals to w sine of alpha plus theta. And if we bring this cos term to the numerator, so we will have cos of phi minus theta whole to the power minus 1. Remember that this is not cos inverse, this is cos to the power minus 1. So now if I take the derivative of this will be dp divided by d phi. This is w sine of alpha plus theta, and the derivative of this will be minus 1 cos of phi minus theta to the power minus 2, since we need to subtract 1 from the power of this. So minus 1 will give us minus 2, and then the derivative of this. So the derivative of this will be sine of phi minus theta. So now we can write that this is this minus, I can write this minus here. So this will be minus w sine alpha plus theta, and then let me write this term first. So this will be sine phi minus theta divided by, we need to bring this to the denominator again. So in the denominator this will become cos phi minus theta square. So this is dp by d phi, and if we equate it equals to 0. So in order to have this equals to 0, the numerator must be equals to 0. So from this we can say that we cannot equate this equals to 0, since this will make this fraction undefined. So only the numerator can be equal to 0 if this is equal to 0. So we can say that minus w sine of alpha plus theta into sine of phi minus theta, this is equal to 0. So now since if we consider that this alpha and this theta, they are constant, so either this term can be equal to 0 or either this term is equal to 0 in order to have the multiplication of both of these equals to 0. So now since phi is involved in this sine of phi minus theta, and we are interested to find this phi, so if this is equal to 0, this whole term will become 0. So we can say that sine of phi minus theta, this is equal to 0. And as we know that sine of 0 degrees is equal to 0. So from this condition, we can say that this phi minus theta, this is equal to 0. So we can write that phi minus theta, this is equal to 0. And from this, phi is equal to theta. So from all this derivation, we come to the conclusion that if that force P is acting at an angle that is equal to theta, if this angle phi, this is equal to theta, and theta is the angle of the resultant with the normal force, and the resultant is and this r is the resultant of this force F and this normal force. So if this angle phi is equal to the angle of the resultant with the normal, so then in that case the force P required will be minimum, that will be as small as possible. So we can find that P. Now if we substitute this phi equals to theta in this equation, so in this equation we can say that, let me write it here. So we can write that P is equal to W sine of alpha plus theta, and in the denominator we have cos of, so phi minus theta is equal to 0 according to this condition. So cos of 0 is equal to 1. So this denominator will become 1. So from this we can say that P will be equal to W sine of alpha plus theta. So this will be that P a small a is possible when this phi equals to theta. So this is that minimum P which is required. So this is the solution of this particular problem. The solution of the second problem is that phi is equal to theta, and corresponding to that phi, this minimum P is equal to W sine of alpha plus theta. So I hope you people would have understood this problem solution. Do subscribe my channel if it helps in your learning. Also like this video and let me know in the comments if it helps in your learning.